Hi everyone, my name is Vikas Nandwana and I'm co-founder and CTO of MFNS Tech. Today I'm going to talk about an environmental remediation platform that is not only innovative but also sustainable and fiscally viable. When we talk about oil contaminated water, we always hear about oil spills. But the fact is produced water is largest wastewater stream that is generated by oil and gas industry. It is contaminated with oil and other impurities which make them unsuitable for discharge to the surface without treatment. Globally, around 250 million barrels of produced water is generated every day, which is almost 3 times of the oil production. In some areas of US, for 1 barrel of oil, 10 barrels of produced water is generated. Unfortunately, on average, only 30% of this water is treated and reused, while 70% is disposed into saltwater disposal wells. However, in recent years, the latter method has come under increased scrutiny from both environmental groups and regulatory agencies, particularly in water stressed areas. As a result, there is a large produced water treatment market measured at $6 billion in 2018 and is expected to increase with 6% CAGR. Further, oil contaminated water is also produced by other industries, and hence there is another oil water separator market which was $11 billion last year and is expected to increase with 4% CAGR. The produced water treatment market is divided into three segments: primary, secondary, and tertiary. Last traces of oil, which are less than 1000 parts per million, are extremely difficult and comes under tertiary treatment. Current state of the art does the job but has their own pain points. Either they are inconsistent, expensive, complex, inefficient, slow, or produced significant hazardous waste. There is not a single method that is economic, efficient, and eco-friendly. And that's where my technology OHM Membrane comes in. I have developed OHM Nanocomposite, which is oleophilic. That means it has high affinity for oil, hierarchical because it provides wide range of porosity to capture various size of oil droplets, and is also multifunctional. That means it can capture other pollutants present in produced water. The coating of OHM nanocomposite on a cellulose substrate converts into an OHM membrane that can sequester oil from any oil-water mixture. The OHM membrane is economic, efficient, and eco-friendly solution for produced water treatment due to the following advantages. The oil from produced water can be removed in one pass. It is made of cost-effective materials. It has selective affinity for oil, is reusable, and can also recover absorbed oil. It is made of environmentally safe materials and methods and produce no hazardous waste. All these advantages make OHM membrane superior to the current state-of-the-art methods for produced water treatment. The unique properties of OHM nanocomposite come from its three-dimensional nanoporous architecture, in which iron-based nanostructures are heterogeneously nucleated within layers of graphitic carbon. Nanostructures are known for their high surface area. The graphitic carbon is oleophilic, but presence of high surface area nanostructures between the graphite flakes results in hierarchical porosity and hence significantly increases the nanocomposite's oleophilic properties. The best part is that the nanocomposite can be synthesized in one step using simple aqueous chemistry under ambient conditions. Hence, it is possible to produce it at large scale in an eco-friendly manner. As you can see in the top right figure, a thin coating of OHM nanocomposite, which is less than 1 micron or 100 times thinner than human hair, is enough to provide its functional properties. The bottom image shows OHM nanocomposite love for oil and resistance for water. Lastly, coating of OHM nanocomposite on cellulose sponge is based on a simple dip coating process which is facile and adaptable to continuous production. Here are some results of OHM membrane. We prepared an emulsion of red dyed oil and water where oil concentration was 1000 parts per million. With a single pass, OHM membrane was able to remove more than 98% of oil. As we see in schematic, when oil-water mix pass through the OHM membrane, oil droplets as small as 1 micron or less can be sequestered by OHM coating, resulting in clean water. This is only possible due to the oleophilic and hierarchical nature of the membrane. We have compared OHM membrane to the currently used filter media such as activated carbon and walnut shell filters, and OHM membrane performed superior to all of them. This is one slide that represents my whole technology. OHM membrane presents a true sustainable solution and contributes to the circular economy due to the 6R principle. Oil can be selectively removed from the produced water. Oil can be recovered by squeezing OHM membrane and recycled. This allows OHM membrane to be reused, and this cycle can be repeated dozens of times. OHM membrane also reduces landfill due to two reasons. It is reusable, so generates less waste, and cellulose sponge that goes to landfill after use can be used as a substrate for OHM membrane. All these steps results in restoring the environment. Last but not the least, this technology is not limited to oil. By modulating OHM nanocomposite coating, applications of OHM technology can be extended to sequester other pollutants such as nutrients, toxins, and microplastics. Due to its amazing potential, OHM technology has received tremendous traction. It has been featured on almost all major media houses. It has achieved a rare feat of featuring on front page of website of National Science Foundation. Our startup also received third place in IMATSI Innovation Showcase, which is a competition for material science startups organized by MRS, Materials Research Society. We were also finalists at Rising Star of the Year award given to early stage deep tech startups in Midwest, organized by MHub and MXD. We are already in communication with 4 companies. Albemarle is mining company, Atlas Copco is a big condenser company, DISA is a startup that deals with soil remediation, and Mormon Waters is a water treatment company. All of them suffer from the oil-water separation issues. Currently, we are doing comparison of OHM membrane with their current media filters, and OHM membrane has performed better than their current media filter at the lab scale. And with this, I would like to conclude my talk and would be happy to answer any questions. Thank you very much for your attention.